Okay, welcome everybody. Today we're going to be doing view of how to do ceiling shop drawings. Now there's two types of shop drawings. There's the engineered shop drawing, which is usually meant for the exterior metal stud system of the exterior part of a building, where an engineer has to calculate how much load and what size stud is needed. That's a whole nother company that we hire in order to do that because they have to stamp the set of drawings. So that's the engineering side. The coordination shop drawings, which is what all of our ceilings normally run under, that's what we're going to be covering today, is coordinating how we're going to be building the ceiling shop drawings and what we need to produce, what needs to be provided in order to fulfill on our shop drawings. Now, part of this comes into having an understanding of construction of ceilings and able to lay the ceilings out and get it documented. So there may be some part where you're going to be doing this on your own and other parts where you're going to be doing this on your own and getting feedback from the field of the actual people installing it to confirm how it will be installed on the project. Okay. So to get started, this is the items that we're going to cover in our slides or in our tutorial today. We're going to cover how to measure ceilings, do a measuring ceiling tutorial on how to do measuring inside a Bluebeam for ceilings. Then we'll do another section, ceiling layout, finding the center, determining which side's going to be the 2-foot side, which side's going to be the 4-foot side. We've got to determine how many whole tiles fit inside the ceiling, how many border tiles fit inside the ceiling. Then we're going to lay out our mains, we're going to lay out our cross, we're going to lay out our wires, we're going to lay out our POF rivets, and we're going to lay out our compression posts. In this presentation today, I've also created links for additional resources where you can watch video tutorials on how to build ceilings that may help bring additional information into how the actual guys install it out in the field, and then how to actually mark up your reflected ceiling plans and create your shop drawings. So that's what we're going to cover today.
How do I subscribe?
Say again?
I was asking how do I subscribe to this YouTube channel?
How do you subscribe to the YouTube channel? You go to I don't know the exact.
No, I'm sorry.
You're making a joke. Gotcha. Yeah, click down below to hit subscribe. That's all you
It's the link below.
Well, you had to be there for a while, so.
So measuring ceilings. So what you want to do is Bluebeam is you're going to open up your drawings in this example, and we're going to look at the reflected ceiling plan. And we're going to want to measure the ceiling that's in room 127. To do that, you need to hit the measure button. You need to go down to calibrate. And when you calibrate, you want to set your scale. So you're going to create a dimension on the set of drawings to say so many inches equals so many feet. Once the calibration is set, you can then begin to measure. The other thing that you need to do that makes taking off ceilings easy is you go down under here where it says snap to. There's a thing that says content. You're going to want to snap content, so it'll look at the image behind and it'll snap to each of the corners, which makes clicking the corners real easy. Okay, once you've set that up, you'll go back into measure and you'll use the area measuring tool. Now, to use the area measuring tool, you just go through and to measure the room, you click on each corner. So you want to run around the perimeter of the room, click each corner. You'll see on the slide that in this case, it highlighted in red and it says 81 square feet in the middle. Once you've measured the room, you need to go to properties, set up our ceilings a certain way to get the most value to do our shop drawing. So we have to change some properties inside of there. So So in properties, we want to change the color to green. We want to change the field color to gray. We want to change the field opacity to 70. We want to click the button that says show segment. You're going to click the button that says show caption. You're going to click the button that says show centroid. And you want to change your text color to green to match the color at the top. Once you've done that, you should get this. So completed measurement will show you all these things. So here's the same takeoff of the room, but you'll see is when you look around the perimeter, you'll see the segment dimensions. So that's where when I asked you to click the segment dimensions, it shows that the room is 8'9" by 9'5" by 8'5" by 9'5". Centroid button will put a green X in the center of the room or the center of the area that you're taking off, so you get a sense of where the center is. And then the caption button will tell you how many square feet of the area. By clicking those three items, that's what will shown when you do your area takeoff. Okay. Now the next section, we're going to go into understanding ceiling layout. Ceiling actually get built and the components of the ceiling and how they get laid out. Now this slideshow that I'm showing right now, I'm going to convert it into a PDF and I'll email it to everybody, or I'll put it onto the put it into our folder structure so that everybody has access to it. And you can use these slides as a directions of what to do to click through. This section here is actually how to build this. So if you're doing reflective ceiling plans, once you understand how ceilings are built, you can skip this section. So this is an optional section when you're trying to build a new ceiling. In the example for this video, we're going to go through how to actually build a ceiling so that you know the parts and pieces and the logic behind it, so that you can understand when you're doing your ceilings to verify where any challenges may come up when you're doing ceilings. So one of the best ways that I found to do ceilings is you open up Google, you open up Google Drive, you go to New, you click Drawings. When you click Drawings, you got to name the drawing sheet. In this example, I named it Project Ceiling Layout. We're going to need to create something that gives us some scale. So you're going to hit Insert Image from Web. You're going to get a side window that pops up, and you're going to want to type in the search term graph paper. When you grab the graph paper, when the image comes up on the right side, you just grab it and drag it and drop it onto your drawing canvas, which is that checkered background in the back of drawings. That's called the canvas. You just drop your graph paper onto that, and that'll give you a chance to create consistent squares and lines. Once you have your graph paper on, we're now going to actually start to draw a ceiling. So you're going to select a shape. In this case, we're going to select a rectangle. And you're going to put it on the graph paper and drag it across to draw the shape of the room. Now, each square represents a foot. So our ceiling, which you see the image over on the right-hand side over in gray, I have turned the ceiling sideways to match what I was drawing, which is, this is an 8'9" by 9'5" ceiling. Okay, so to do an 8'9" ceiling, I drew 9 squares across, and then I drew 9.5 squares up to give us that ceiling space. So that's the area spacing we're working with. Once you've done that, you're going to want to change the fill color to be transparent. So you'll get something that looks like this. You should get a square based on the canvas, and it should look transparent. Once we've determined the outline of the room, We now need to determine how many ceiling tiles and grid are needed to make up the ceiling. So to start to do that, we have to determine the center of the room. We're then going to calculate how many whole tiles are needed, and then we're going to calculate how many border cut tiles are needed. And there's two sides of the room. One side is going to be 2-foot side, and the other side is going to be a 4-foot side. So to determine the center when you're in Google Drawings is when you hover over the middle of the line, you'll see a purple dot that comes up. And when you do that, you're going to create a line from top to bottom to mid-center. If you're doing this on a piece of paper, you just measure the distance across and divide it in half. That determines the half of that line, and that determines the other half of the other line. You draw a line in between to determine center. All ceilings are typically, ceilings are determined from center working outwards towards the edge. So you always start with the center point and do your dimensions and everything for ceilings working out towards the border. So in this example, you can see in the upper left, it says there's the center. Now what we need to do is we need to determine which side is going to be the 4-foot side and which side is going to be the 2-foot side. To determine which is going to be the 4-foot side, meaning that the main tees, which are spaced 4 feet apart, are going to be running, and which side the 2-foot tees are going to be running. Typically, you want your mains to go the longest distance of the ceiling. In this example, the 9'5" side is the longest, so we want our main tees to run parallel to the longest side, which then means our 2-foot tees will run perpendicular to the longest side. So now we need to determine whole tiles. And this is where we're going to be doing some calculations to determine how many whole tiles fit inside of the ceiling. To do that, you're going to want to take the dimension of 9'5", divide by the tile size, either 2-foot or 4-foot. Since this is the 9'5" side, you're going to want to divide by 2. So you'll see there in blue, the calculation is 9'5" divides by 2 feet equals 4.708333. That determines how many whole tiles we need. So what that means is that you can fit a quantity of 4 whole 2-foot tiles inside of that space, going the length of the room. Okay? Now there's going to be a remainder. You see the 0.7083? What we're just trying to determine is how many full tiles fit in. In this case, it's 4. Now we're going to go into the section where we're going to take a look at, well, now we need to figure out the dimension of the border tiles. So we know that we can fit 4 whole tiles in the space. Now let's figure out the border pieces. To do that, you take the 4 whole tiles times its width, which is 2 feet, which equals 8 feet in total, and you subtract that from the whole length of the wall, which is 9'5", which gives you a remainder of 1'5" at the border. So you're going to have borders 1'5". To have you look at that and represent that, if you look in the upper left side, you'll see here, this is what the layout would look like. You would have 1, 2, 3, 4 full tiles working from the center, and at the edges, you're going to have 2 border tiles. The remaining space you have is 1'5", but you have to divide that in 2 so that you can balance your ceiling to make it equal on both sides. So what we have to now do is determine what is this dimension. How big will this tile be? To do that, You take your formula that you did. We determined the borders. You had 4 full tiles, all at 2 foot, which equals 8 foot. You take 8 foot minus the 9.5, which means that you have 1 foot 5 inches remaining here and here. And you got to take the 1 foot 5 and you have to divide it by 2, equaling 8.5 inches. So this piece and this piece up here will be 8.5 inches. If the borders are less than 12 inches, or said another way, or less than 1 foot, then what you do is you reduce by 1 full tile and you redo the calculation. Because 8.5 inches is too small, is too small of a cut, that you would prefer to have a wider tile for, means less labor for installing the grid system, and it gives you a longer full tile length to fit inside of the space. So in this example, since the 8.5 inches is too small, what we're going to do is we're going to reduce by 1 tile. So you'll see up here we had 4 tiles. Down here we have 3 full tiles. Since it's 3, the middle tile has to be put in the center of the line. So now we have 3 full tiles. 3 full tiles times 2 feet is 6. So we have 6 total feet being used. You take 6 minus the 9 foot 5, which gives you a remainder of 3 foot 5 inches at the border. You take 3 foot 5 inches, divide by 2, which then means you have a space of 1 foot 8.5 inches at the borders. You now have a balanced ceiling for this side. You do this for the 2 foot side, then you go through and you do the same thing for the 8 foot 9 side. Okay, and down here I put, if you don't have the calculator, you can download it off the App Store. You want to look for this free calculator that allows you to do all these calculations. Okay, for the next section is, I already did the calculations for this side, and you would come out with the ceiling looking like this. You'd have 3 2-foot tiles going this way with 1 foot 8.5 by 1 foot 8.5. And on this side, you're going to have 1 4-foot tile by a 2 foot 4.5 by 2 foot 4.5. So here's your layout of your ceiling. So the area in white is where we want to put in our main tees. Our main tees come off the center. They need to be centered around the center. And since it's 4 foot, you're going to go 2 foot this way and 2 foot this way to make up. And this is where you're going to lay your main tees, which are here in orange. You put your 2 main tees. Once your main tees are established, you then create your cross tees. Your cross tees, which are here in blue, which is a continuation of these lines here. Coming across. You now have a gridded system. You now have your mains and you have your cross tees. Once you have your mains and your cross tees established, wires need to be attached at certain points in order to hold up your ceiling. So to lay out the wires are attached at every 4 feet. In this example, you want to start close to the center here, and you put your wires close to the center and work a direction. In this case, I worked up. So I started here. I'm going to put a wire here on the mains. The mains are the only thing that receives wires. So put a wire here, 4 feet this direction, a wire. 4 feet this direction, I'm at the edge of the wall and no wire is required because it's attaching to the wall. 4 feet this direction needs a wire, and 4 feet this direction needs a wire. So there'll be 4 wires placed in this ceiling to support this ceiling structure. On some projects, a pop rivet is required to attach the main to your wall angle, which is at the edge of the perimeter of your ceiling. So some shop drawings require you to put a pop rivet into it. And to identify that, we use a yellow P, and you put that on your shop drawings to identify where the pop rivet will go. In this case, I put the pop rivet along this main over here at the wall. Typically, only one prop is needed per ceiling for seismic reasons. In case the suspended ceiling, they want to tie it into the wall to make a rigid connection. And you typically locate the pop rivet to the least visible side, meaning that wherever people walk into the room or a lot of heavy traffic walks in and out of the room, the access and egress point, you want to put it on the far side where it's going to be the less visible. In this case, I put it, I think there's a door over here, and I moved it all the way across to the other side so that people don't see it in the back corner. On some projects, for ceilings that have over 1,000 square foot ceiling, a compression post will need to be added, which is a rigid connection that allows the ceiling to stay firmly attached to the deck or the joists above. Since this ceiling is so small, a compression post is not needed for this ceiling. However, in this example, I'm just showing you as a reference how you would label and put a compression post in. Just put it up here. This is the symbol, and this is what it would look like. Okay. Now, I've also attached additional resources on how to install suspended ceiling. So on this slide, there's lots of resources available from different manufacturers. There's 3 typical suspended ceiling manufacturers that get used for suspended ceiling. USG/Dawn. So there was a company called Dawn Ceilings that they merged with USG. USG purchased them, and so now you've got a USG Dawn ceiling system, which is what we typically use because it's provided by Foundation Building Material. Another ceiling manufacturer is called Armstrong, and the other one is CertainTeed. Each one of these ceiling manufacturers has their own YouTube channel and websites full of a lot of useful information. So I pulled some of this information off their website for us to easily access to help understand something. So you can click on any of these links on the slides. It'll tell you this is a 7-minute video of how to install ceilings. Here, these are additional, more full length, more in depth. CertainTeed does a 5-minute video on how they plan their ceilings out. Now here's another critical website that is very useful when trying to plot and plan out and create ceilings. So this link here, Armstrong Ceilings, has a drop ceiling calculator. You put in the dimensions, and it will determine your mains, your cross tees, your wires, and your wall angle, and it'll produce a material list. So you just have to tell it the dimensions of the ceiling, and it'll automatically calculate all that stuff for you. The challenge with using Armstrong stuff is that when it produces the material list, it produces the material list in Armstrong ceiling components. So if you're using a USG ceiling components on a project, you can use this tool to determine your layout and quantities, but you would have to convert it to not use Armstrong. You'd have to hide the descriptions of the material and convert it into USG. Okay, now we're going to talk about, well, are there any questions or comments about anything we've covered so far in layout, or construct ceilings?
No.
Okay. So the next section we're going to be talking about is marking up the reflected ceiling plans. Actually now going in and applying what we did when we built the ceiling to actually putting it onto the ceiling on the reflected ceiling plan. So whenever we're dealing with an architectural's reflected ceiling plans, the architectural drawings typically have a rough ceiling layout showing important elements of the ceiling. So the architect has already gone through and put certain things in certain places to give kind of an intent of how they want the lighting and diffusers and sprinkler heads and the ceiling to be kind of laid out. So in this example, you'll see that there's lights, diffusers, and vents. So you can see that the light is in the center of the room, and then there's vents to each side of it, and then they've also located, there's a sprinkler head. And the sprinkler head is along a line up here that says center line. So you'll see a CL, that means center line. That's determining that they want the sprinkler head to be in the center of this room. So shop drawings, the reason why coordination shop drawings are needed is that the electrician, the mechanical company that's installing the vents and the ducts and the fire sprinkler system need to know where we're placing our ceilings, where we're going to place our wires, where our grid's going to be laid out, so they can make sure that they get dimensions to where our ceiling's going to be placed so they can put their light there. So they'll need to put enough wire in there to extend to get to that light. The mechanical guys will need to put their layout inside of our ceiling. So we have to provide layout for them so they can say, okay, I've got to put enough duct work to extend to hit those marks. Now to determine how your ceiling is going to be marked up, in your drawings, in your set of drawings, there's details. And it will show the requirements for what's needed to make the ceiling. So in this example, you'll see that the orange lines, this is detail number 5 on one of the pages. You'll see that there's the main runners identified that I've highlighted in orange. The cross runners are blue. And you'll see over on the side it says 2 foot typical. Then in the upper left-hand corner, you'll see in red, it says 12 gauge vertical hangers at 4 foot on center, each way at main runners with a minimum of 3 tight turns in 3 inches at both ends. And you can see additional details to see what they're talking about the wires. So the wires are a little bit skinny, but you can see them pointing out up here, 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 here. So every 4 feet, they have a wire. This dimension here just says that if any deviation from plumb, meaning if this wire cannot go straight up, for every 1 inch it's deviated, you need to add 6 inches of wire. So that way, if you have to get around a duct or something like that, it has to meet this requirement when changing the wire. Now, in the center here, you're going to see what they refer to as a rigid vertical strut, which is sometimes also called a compression post. So if a compression post is required, this is what it would look like, and then you can look at these details for showing for locations and bracing of wires and strut, where this will be required on large ceilings that are anything over.
On the compression post, guys, typically a compression post is nothing but a piece of black iron, 1.5-inch black iron, or a scrap piece of steel. But you have to check, because I looked at one last week on a job that Chris was looking at, and it almost looked like a shock absorber. So just something to be aware of. Most of the time it's just scrap steel.
So now that we understand all those components, what we now want to do is we want to actually put our layout of our mains and our T's, our wires and our posts, and our POF rivets on this reflected ceiling plan. So to start, you got to create a legend. So you're going to create a big box on your sheet that identifies your legend with mains, T's, wires, and POF rivets. To do that, what I do, so once you've created a box and you've typed in those words, Then what you're going to do is you're actually going to go to your markup tools and use the poly length, and you're going to create this symbol here, create a line that's orange for mains, poly length, blue for tool, blue for cross keys. You're going to use the text box tool to create a red X, and you're going to use a text box tool to create a P in yellow, and you'll change that all in the properties to create this legend box. First, you type in the words, then you got to put in the symbols. So now we begin to measure the ceiling. Using the polylink tool, you come through and you measure, you start at one end, and whenever you're doing your ceilings, always start from the same side and work in the same direction. Okay, so from here, I clicked 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 here. And what that does is that tells me the dimension of each segment. So this corner piece, this border piece is 1 foot 1 inches, then 2 feet, then 2 feet, then 2 feet, then 1 foot 7. So if you can see in our example that the ceiling that we laid out, we put 2 foot 8.5 inches at each border piece to balance the ceiling. This architect wants to have the ceiling not be balanced. They want the ceiling to be balanced from one side and then take up the difference on the other side. Because they have so much stuff going on in the ceiling, they want the ceiling to look this way. So the architect, we want to follow the architect's layout because they put in consideration all the stuff we didn't. We didn't have lights in our ceiling layout. We didn't have vents. We didn't have fire sprinklers. So they've compensated for that and laid their ceiling out a certain. So in this example, I did the same thing. On a polylink, you just click here, click, 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 create a straight line, and it will automatically tell you your segments and tell you your full dimension. As you can see, this part of the ceiling is 8 foot 8, and the length of this main tee is 8 foot 6. So this ceiling has a slight tilt to it and is shorter on one side. So we've established our mains. Next is establishing the cross tees. To establish the cross tees, use the polylink tool again, and this time it's going to be in blue. You click, 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 click. You do that across all your lines. As you do that, you can see that this side of the room, the length of the cross tees, the total length of the width of this room is 9 foot 5 inches, 9 foot 5 inches, 9 foot 5 inches, 9 foot 5 inches. So this part of the room is square, and that each of the middle sections is exactly 4 feet. This perimeter border piece will all be 2 foot 8, and this perimeter border piece will all be 2 foot 10 inches. So we'll have consistency around there with the cross tees. Now, worth noting is you see this vent system here and this vent system here. Anywhere there's something that interrupts the ceilings, an additional cross tee will need to be put in place for our ceiling to lean up against to. So this cross tee and this cross tee needs to be marked that we're showing that we are creating a perimeter edge at anything that interrupts the ceiling. Next step is identifying wires. As in our other example, when we were creating our ceiling, you want to start from the center, put a wire here, 4 feet over, wire here, 4 feet over, wire here, 4 feet over, wire here. These are the 4 wires that will occur in the ceilings, and the lighting guys need to know that when they're installing their light, that we're going to have a wire here and a wire here. And then if we're going to install a pop rivet, if applicable, and you'll have to look at your drawings to see if a pop rivet is required by code or not. Say if a pop rivet was, it would be applied over on this side. I traditionally don't put pop rivets on unless I confirm with the field or check in with the GC on what the inspector is going to need for their ceilings, if they want to see it or not for our shop drawing. Once we've marked up all these items, I usually create a Excel sheet. In this case, I created a Google sheet. And if I'm doing lots of different ceilings on a project, I usually create a layout saying what room number, how many square feet, how many mains, how many 4-foot cross tees, how many 2-foot cross tees, how many wires, how much wall angle, and how much ceiling tile is going to be needed for that room. I usually provide that as a reference to say this is what we're anticipating. This is the material that's needed in there. The reason we produce a material list. One, it helps our team out in the field. Two, is that when that's provided as part of our shop drawings, is that if there are any changes, it may increase our material, and we can demonstrate and show that. Say, hey, look, because the lighting needs to move or do something, you've added 2 more tiles into the space or 2 more cross tees, which means there's additional material and labor needed in order to do that. So once you've done your layout and you've created a list of your rooms, you've now created your ceiling coordination shop drawings that can be submitted over to the general contractor in the submittal form. Any questions or comments about anything we've covered?
Nope.
James, Granger, anybody?
Granger stepped out and Chelsea stepped out.
Okay. Aloima, based off what we just covered, do you think you will be able to make ceiling shop drawings for the pump room project?
I can try.
Good answer.
Are you going to send that video?
Yeah, so I have the video. So what I'm going to do is I'm going to show you an example of doing it live right now.
Okay.
I'm going to